Okay, this is going to be the last unit on trig proofs and trig equations. A little bit different. I'm not going to do the actual worksheet because there's a lot to write down. I don't know if it's going to fit all in the space. There's some stuff also that I want to give you at the beginning for you to write down that will help you. So for instance, there are some things on the trig proofs. So if you start on the trig proof side of it, all right, on the proof side of it, what you're going to need to know, all right, is the conversions from sine is going to be y over r, cosine will be x over r, tangent will be y over x, all right, cosecant will be r over y, secant will be r over x, and cotangent, okay, will be x over y, all right? Just make sure that you guys can see that. It's on the video screen. Yep, we're good. Okay, now what you'll be given in the trig proofs, you'll be given that x squared plus y squared equals r squared, that y squared plus x squared equals r squared minus x squared equals y squared, and r squared minus y squared equals x squared. So you'll be given that. You'll have to know these. Okay, and I'd write these down on your blank sheet of paper when you start, and you'll be given this. So as you work through this, I would have this on a separate sheet of paper because I'm going to reference it as we go. Okay, so let's go ahead and start with question number 1. Okay, you got sine squared theta plus cosine squared theta equals 1. So what you're going to do is you're going to replace sine with y over r. Since it's squared, that's like that. Cosine will be x over r. Since it's squared, it will look like that. 1's going to stay 1. Now, since we're adding fractions, we need a common denominator, which is nice. We already have one, which is r squared. Now, what I can do is I can push those together. Okay? So what I got is this in your givens turns into r squared. So r squared over r squared equals 1. And anything you divide by itself will be 1. So 1 equals 1. Okay? If you wanted to also, you could have done r squared divided by r squared. Okay? All right, obviously that would flip that over, and those would cross out. So you can done either way. Okay? Number 2, all right, 1 plus y squared over x squared, that would be tangent. Let me write down the actual problem so you guys aren't confused, because you're working off the worksheet. So 1 plus tan squared of theta plus equals secant squared of theta. So that's 1 plus y squared over x squared equals r squared over x squared. Okay? Now, here you have fractions, addition of fractions. So what you want to get is a common denominator. So this is over 1. Okay, this side's missing x squared. So I put that, x squared and x squared. This side's missing 1. So my common denominator is x squared, okay? X squared, now I can multiply these, then push them together. So that's going to be x squared, that would be y squared. So if you look in your givens, x squared and y squared is r squared. So r squared equals r squared over x squared. So you have to show both sides, okay? All right, like I said, that's why I'm doing it on paper, so we have enough room. Okay, so number 3 is cotangent of theta is cosine of theta over sine of theta. Okay? So what I got here is that's going to be x over y, and that's going to equal x over r divided by y over r. Now, another way to write that is x over r divided by y over r. Now, in division of fractions, what happens? That part stays the same, but this part's going to flip and turn into multiplication. So what's going to happen is the r's can cross out, so I'm left with x over y. On this side, I got x over y. All right, moving on to number 4. Number 4 says tan theta, sine of theta, equals 1 minus cosine squared of theta over cosine theta. Okay, so what this is going to turn into is y over x times y over r. Okay, so what I got is I got y squared y squared over xr. All right, so if I look over here, all right, I'm going to turn that into 1 minus x squared over r squared divided by x over r. Okay, So what I got is I got a common denominator deal just like that other one, so that's going to need to be a 1. This side's missing an r squared, so I put that on top of the bottom. This side's missing 1. So what I got is r squared minus x squared all over r squared, okay? And as you can see, what I can do is I can push those together. Now in your givens, that's going to be y squared. So y squared over r squared divided by, okay, x over r, okay? So what's going to happen is you're going to flip that fraction, okay? And now what can eliminate? One of those r's. So the r squared will cross off and be r. So what I got is I got y squared up top, xr on the bottom, and over here I got y squared up top and x over r on the bottom. Okay? Let's move on to question 5. All right. 5 is sine squared theta over 1 minus cosine theta equals 1 plus cosine theta. All right? So what this is going to be is y squared over r squared divided by 1 minus x over r. All right? So now no square down here, so you got to be careful. So, all right, so this side is missing an r, so r and r. This side's missing a 1. All right? So I got r minus x all over r. Okay? So my division, so what I have is y squared over r squared divided by r minus x over r. So what I'm going to do is I'm going to flip that. So it's going to be y squared times r, okay, and this is going to be r minus x. Okay, so that's going to cancel, okay, and what I'm going to have is y squared and then r times r minus x. All right, now let's see what goes on over here. All right, so I got 1 plus x over r, okay, so what's going to happen is that's going to be r and r. All right, so that's r plus x all over r, okay, all right, I don't think that one works. That's not good. So don't worry about number 5, because I don't, let me see if I made a mistake. So it's y squared over r squared, okay, 1 minus, I think this is supposed to be a squared. That's probably going to make that work. So maybe this was squared was left off. Let's see if that fixed it. That would make that r squared minus x squared, which that would be y squared. Yeah, I don't know why that's not working with that. Okay, just don't worry. You can go ahead and skip number 5. I don't think that trig proof works. All right, so in number 6, okay, let's go on to number 6. So I got cotangent of theta minus 1 equals cosecant of theta minus secant theta over secant theta. All right, so that's going to be r over y minus r over x divided by r over x. Okay, once again, I got this side's missing an x, this side's missing a y. Okay, so I got xr minus ry all over xy, okay, divided by r over x, so xr minus ry over xy times, now that flips that fraction, so I can cross off the x's, and since both of these have r's, I can cross off the r, so what I'm left with is x minus y all over y. Okay, let's see what this side works out to. I got x over y minus 1. Okay, this needs a common denominator as well. This is missing a y. This is missing a 1. So I got x minus y all over y. So those are the same. So those end up working. I don't know what happened on this one. I don't know if there's something incorrect there. Yeah, that's got to be cosine. Right? It's x over r. Okay, this side's missing, so that's r minus x. That's right, over r. Okay, that would flip. Okay, that's y squared over r. Okay, yeah, I'm unsure why that didn't eliminate. So we'll just go ahead and skip number 5. Don't worry about it. Number 7, secant of theta over cosine of theta minus 1 equals tangent squared of theta. Okay, so what you got here is you got r over x okay? All right? And divided by x over r, all right? Minus 1 over here. So what I got to do is figure out this fraction. So r over x divided by x over r. So that's going to be r squared over x squared. Because when I flip this, well, let me not skip the step there. So you guys don't get confused. So it's r over x times r over x, which is r squared over x squared. Okay? So I got that minus 1. Okay? So what I'm going to need is a common denominator. This side's missing an x squared, this side's missing an x squared, this side's missing a 1. Alright? So what I got is a common denominator of x squared. I got r squared minus x squared. Now, that would give me y squared. So y squared over x squared. If you look at what tangent squared is y squared over x squared. So you're good. So what you had to do is the division here, then do a common denominator. Okay? Last proof, question 8. I got cosine of theta, secant of theta, minus tan of theta. 1 plus sine of theta. Alright, so I got x over r, big division sign, r over x, minus y over x. Okay? Alright, now, I already have a common denominator there, so I can just push those together. Alright, now, I've got x over r divided by, alright, r minus y over x. Okay? So what's going to happen here is this is going to be x over r times x over r minus y. Okay, so I got x squared over r squared minus, or r times r minus y. Okay, I think number 8 doesn't work either for whatever reason. Let me double check that. So I got x over r, so r over x minus y over x. Okay, so that's r minus y over x. Okay, divided by that. It should flip. It probably should have been secant. Okay, let's see what happens over here. This needs an r. This needs an r, so I got r plus y over r. Okay, yeah, I think this one's no good either. Sorry about that. So 5 and 8, don't worry about it. Okay, they don't work out. Okay, all right. Let's go back to the trig. Let's go down to the trig equation. So basically, in 5 and 8, those end up not working. Those other ones should give you a good idea what to do. All right. So a couple things when you go into the trig equations part. All right, you're going to compare. All right, you're either going to have a 0, a 90, a 180, a 270 comparison, or you're going to have one of 3 bow ties. And what I would do is I would write this down, and this will dramatically help you speed through the process. That would be 30. In this quadrant, this angle would be 330 because we compare to 360. These two we compare to 180, so that's 210 and 150. All right. The other bow tie you're going to have is you could have a 60 bow tie. That's going to be 60 because it compares to 0. This would be 300. This would compare to 180, so that's 240 and 120. Okay, so that's one of them, and the last one is the 45 bow tie. So I would draw these out because this will make the process easier for you as you go. 45, 135, 225, and 315. Same comparisons to 360 and to 180. So I would write that down. Take a second to write that down. You're going to have one of these 4 scenarios or a combination of them as you go. All right? So let's go ahead to move to question 8. All right? So what you do on question 8, all right, you're going to sub out cosine x for x. So this turns into 2x minus 1 equals 0. You solve it like a regular equation. Add 1, divide by 2. Okay? So I got x equals 1/2. Now, what you do is you bring back the cosine. Okay, so you solve it to x, then bring back your original. Then you do inverse of 1/2, and you want to see what you get. All right, that's 60 degrees. So the first angle that works is 60. Okay, so when you look back at this bow tie, you know that these would be the other angles that you're going to try. Okay, so what I'm going to try is I'm going to try cosine of 120, cosine of 240, and cosine of 300. Knowing that the 61 already works. Now, let's figure out what cosine of 60. It's going to be 1/2, but if you type it in, it's 0.5. So I want to find the other ones that give you 0.5. Well, cosine of 120 is negative 0.5, so that one's no good. Cosine of 240 is negative 0.5, which is no good. But then cosine of 300 is 0.5. So that's the other one. So that one we know works, so this other one works as well. So the two answers are 60 and 300. Okay? Going on to question 9, you got 3 tan of x plus square root of 3 equals 0. Okay? So we're going to replace 3x plus square root of 3 equals 0. All right? So x for tan. Okay? So what I got, I'm going to move that by subtraction. That's the square root. So 3x equals negative square root of 3. Divide by 3. So I got x equals negative square root of 3 over 3. I'm going to bring back the tan. Okay? And then I'm going to take inverse tan. All right? And let's see the first angle that works. All right, first angle that works is negative 30. Now I don't want negative 30. I'm going to add 360. So the first angle that worked was 330 degrees. Okay? Now, going back to look at this, which scenario is that? Boom, it's that one. Okay? So I'm going to do 30, 50, 110 are the other ones that I'm going to do. So tan of 30, tan of 150, tan of 210. Okay, now, let's figure out what the tan of 330 is. Just so you get a decimal. That's negative 0.57. So what I want to do is find the other one that gives me negative 0.57. Well, tan of 30 gives me 0.57. So that's no good. The tan of 150 gives me negative 0.57. So I think that's going to be another one that works. Okay, and then tan of 210 gives me 0.57. So as you can see, okay, this has to match my original. So the two that worked were 330 and 150. Okay, let's go to question number 10. Okay, all right, question number 10. So you got 4 sine squared of x equals 3. All right, so I'm going to replace sine with x. So I got 4x squared equals 3. I'm going to divide by 4. That's x squared equals 3. I'm going to take a big square root. So that's x, and now big square root of 3 over 4. Okay? Inverse sine of big square root of 3 over 4. Okay? All right? And so, sorry, I should have brought that back. So sine of x equals this. Okay? So I do big sine of inverse. Now, it's very important that we put a fraction of 3/4. Okay? Make sure you close that. Okay? So the first angle that worked was 60 degrees. Okay? So if you go back and look at your other ones, which one's the 60? So 120, 240, 300. Those are the other ones I got to check. All right? So sine of 60 worked. All right? Already know that. So sine of 120, sine of 240, sine of 300. All right? So let's figure out what the sine of 60 is, and then we'll just match it. Sine of 60 is 0.86. So all I got to do is match the 0.86, and I'm good. Okay? Sine of 120. 0.86, all right, that's 1. And then you're going to see how the other two don't work. Okay, sine of that, and then sine of 300. All right, in the interest of time, you'll see how both of those are negative 0.6, which we do not use. All right, so those don't work, so the two that work were those. All right, let's go on to, we only have 4 left, so we're going to go to 11. All right, I'm going to go ahead and replace cosine with x. Okay, so what you got is 3x minus 7 equals 4x minus 6. Now that you can see the replacements there. Okay, so what I'm going to do is I'm going to go ahead and subtract the 4x. So I got negative 1x minus 7 equals negative 6. Add 7. I got negative 1x equals 1. Divide by negative 1. I got x equals negative 1. I'm going to put the cosine of x back in. And then take inverse cosine of negative 1. Okay, now if I do inverse cosine of negative 1, what it tells me is it tells me 180 degrees. That's the first one that worked. Now, here's what I do. I go back to this. These are these. It's not a bow tie. So the only ones I got to try are cosine of 0. Well, let's do cosine of 180 first, all right, which we know works. Cosine of 0, cosine of 90, cosine of 270. You don't have to do 360 because it's already been done with 0. Okay, so let's figure out what cosine of 180 is. Cosine of 180 is negative 1. All right, cosine of 0 is 1, so that's no good. Okay, cosine of 90 is 0. That definitely doesn't work. And then cosine of 270. That's also going to be 0. Yep. So that's 0, so that doesn't work. So the only one that worked there was 180. Okay? All right. Now, moving on to question 12. All right. 12 says 2 sine squared of x plus 3 sine of x plus 1 equals 0. Now, I'm going to sub out x for sine. So what I got is I got 2x squared plus 3x plus 1 equals 0. Now, when you have it's different than the other one. When you have multiple variables in there, you're going to go to equa in your calculator to help you solve that. All right, so I go to menu and equa, degree 2, 2, 3, and 1. Okay, so I get x equals negative 1/2, and x equals negative 1, and I'm going to do sine inverse of negative 1/2. Okay. Oops, let me go back to this. Okay, sine inverse of negative 1/2 gives me negative 30, which I would rather have a positive angle. So the first one that worked was 330. Okay, and then what I do is, let's go back, where's 330 located? 330 is located, boom, so 30, 150, 210. All right, so let's find out what sine of 330 is. It's negative 0.5, so we're going to find all the ones that match. Okay, sine of 30 is positive. Sine of 30 is positive. Sine of 150 is positive. Sine of 210. Okay, so these were 0.5, 0.5, and negative 0.5. Well, my original was negative 0.5, so I want this one. So these two work, and then I'm going to do sine of inverse of negative 1. And you'll see that that is going to be negative 90. Add 360, that's going to be 270. So the first one that worked was 270. So I'm going to just use 0, 90, and 180. As you can see, those are those ones that all link together. All right, so I know that works as well. Okay, whoops, sine of 270 is negative 1. So I'm looking for all those that match. Sine of 0, 0, sine of 90, 1, sine of 180, 0. So 0, 1, and 0. Well, none of those work. So what's my answers? 330, 210, 270. Okay, 2 more problems and we're done. All right, so 13, you got tan squared of x equals tan. I'm going to sub out. Now what I got to do is I got to move this back over, so that when that moves back over, it'll be negative x. I got to go to equa to figure this out. Okay, now the number in front of x squared is 1, the number in front of x is negative 1, and the standalone number is 0. Okay, so what I got is x equals 1 and x equals 0. All right, so I got tan of x equals 1, tan of x equals 0. All right, inverse tangent of 1 is going to be (45). Okay, so I know tan of 45 works. Okay, and that's going to be those guys. Okay, tan of 135, tan of 225, tan of 315. Okay, so I got to find the tan. It's going to equal 1. Okay, so if you want to see tan of 45 is 1, tan of 135 is -1, tan of 225 is 1. Okay, so that was -1, no good. This was good because it's 1, it matches that. And then tan of 315 is -1. All right, so that didn't work. So 45, 225. Tan of 0 is 0, so we've got 0 degrees works. All right, so tan of 0 happens to be 0, so we got 0 and 0. So now we're just going to try 90, we're going to try 180, we're going to try 270. And you can see how they all group together, okay? So tan of 90 is undefined, that's going to be undefined. Tan of 180, whoops, is 0. Tan of 270 is, once again, that is going to be undefined. So the ones that work were 180, so the 45, 25, 0, and 180. Okay, last problem, very similar to question 11. 15x plus 19 equals 14x plus 18. Subtract the 14x. That's 1x plus 19 equals 18. Subtract the 19. 1x equals -1. Okay, divide by 1, x equals -1. Okay, we're going to put sign back in. Okay, and it's the same thing as before. It's going to be -90, which that ends up being 270 degrees. Okay, it's the first one. My video's got to wrap up. This bell's about to ring. Sine of 90 is 1. Sine of 180 is 0. And the sine of 0 is 0. So the only one that worked there was 270. Okay? So go back and look at those bow ties. Go back and look at that stuff at the beginning. Practice some of those. You should be fine.